Hey again everyone, and welcome to this video in our series on linear relationships. In this video we're going to start to look at bits and pieces around simultaneous equations. So this is where we find the value of the coordinates where two lines might meet. So we're solving two things. It often comes in as a break-even point in a profit-loss sort of situation for a company, things like that. Okay, now we can look here. It involves finding a solution that satisfies the two equations. Okay, if lines are not parallel, so when lines are not parallel, and not parallel like the ones below there, we have a single unique solution. Okay, and that's that one spot where they cross each other. If you look at that, we call it the point of intersection. Okay, so we want to find that point of intersection. Now, if they happen to be parallel lines, i.e. they have the same gradient, well, unfortunately, that means there's not going to be a point of intersection. There's no point of intersection, so there's no solution. And that can happen occasionally as well. Okay. The method we're looking at in this video is the substitution method. So what we're looking for is we're going to substitute an equation into the other one. Okay, so this entails substituting one equation into another. That's the gist of it, okay? Long and the short, this is exactly what we're looking at. So as an example, e.g., if we have, say, x plus y equals 8, and we have y equals 3x plus 4, then we actually know something about the value of y, okay? And we can substitute in that equation, or that expression from that equation, because that's what y equals, into the other and solve it just like normal algebra. So we would substitute this expression as the value of y. And that's essentially all we're going to be doing for substitution method for solving simultaneous equations. Let's have a look at a couple of examples in this sort of method, or on this method. Let's see it in action. Okay, so here's a pair of equations. We have 2x minus 3y equals minus 8, and y equals x plus 3. So what I'm going to do is I'm actually going to substitute that in for y. Because I know that that's the value of y. Okay? So all I'm going to do is I'm going to go 2x minus 3y equals minus 8. But I'm now going to substitute in. So the 3y, so I've got 2x minus 3. And then I'm going to put in brackets because I'm substituting in. And it's x plus 3. That whole of x plus 3 is what y equals. The x plus 3. I'm going to expand it all out. Okay, so it's going to be minus 3x plus, or rather minus 9. There's our expanded equation. I'm going to collect some like terms there. I have minus x minus 9 equals minus 8. If I add 9 to both sides, I get minus x equals 1, but that's a minus x, so I times both sides by minus 1. And I get x equals minus 1. So because x equals minus 1 now, we can now substitute into the next equation. Okay, so I'm going to substitute in for x. So I'm going to have y equals x plus 3, because that's going to be the easiest one to do it for. Y equals minus 1 plus 3, which is going to be 2. So our answer here is x equals minus 1 and y equals 2. And there, ladies and gents, is our answer. Now, we do have another pair of equations to look at, and we can do a very similar thing. Now, for these ones, both equations is y equals something. So the expression over here, if I dig out a different color, this expression has the same value as this expression. They both equal y. So they have to equal each other. So they have the same value. So let's start there. Now I'll just pop in a little line so I don't get them mixed up. So I know now that minus 3x plus 2 is the same as 7x minus 8. Okay. Now, because I've got some negatives in there, I'm going to go a little bit backwards in terms of what I'm doing. I'm actually going to add 8 to both sides. It's going to give me minus 3x plus 10 equals 7x. Then I'm going to add 3x to both sides. It's going to give me 10 equals 10x. I divide both sides by 10. And I'm going to be left with x equals 1. So I've got x equals 1 for this one. So now I substitute that 1 into one of my equations to get y. So now I substitute in. So I substitute for x. So I'm just going to pick, the second equation there, the y equals 7x minus 8. It's going to be a little bit easier to work with. And now I substitute in the 1. Okay, so now we're going to have 7 times 1, which is 7 minus 8, which means that y equals minus 1. So in this particular one, and we can double check this by popping both those numbers, the 1 and the minus 1, into the first equation, the y equals minus 3x plus 2. Or we can just accept that x equals 1 and y equals minus 1. So there's the answer to our second problem there. Hopefully this video has helped you, given you some things to think about in terms of doing simultaneous equations using this substitution method. Hopefully it has given you a bit more insight and a bit of help with your problems. Good luck with those questions, and thanks for watching.